Hello class, welcome back to lesson 2. This lesson is about valence electrons and ions. So today's objective is to basically identify what are valence electrons, understand what ions are, and figure out what the difference is between what a cation is and what an anion is. And lastly, understand how to use the periodic table to basically show the different charges of different ions. So there are two different models that we will be using in class. The first one is called the Bohr's model, and then the second one is called the Lewis dot structure. All right, so you can remember Bohr's model, it has rings on it, and Lewis dot structures, the word dot means that there's just like dots everywhere. So let's start by talking about the Bohr's model. So this is a picture that has a lot of different rings on it. There's a lot of really good information in this picture. The first one is about the nucleus. The nucleus holds, if you remember, the protons and the neutrons of an atom. So if you count how many yellow little dots are in the center and the pink little dots, that will tell you the number of protons and the number of neutrons. If you look at the Bohr's model, you can see this inner ring right here. This inner ring holds up to 2 electrons. It can only hold 2 electrons. The second ring, this one over here, this holds a total of 8 electrons. All right, and the outer ring, if you remember from your chemistry class, the outer ring can hold also up to 8 electrons. All right, and that's kind of just the rule of Bohr's model. You need to remember how many electrons each energy level can hold. All right, so 2, 8, and 8. So Bohr's model tells you basically electrons are kept in different types of energy levels that wrap around the nucleus of an atom. The electrons that are on the outermost ring, we call them our valence electrons. So on this outer ring right here, this is where you're going to find your valence electrons. So if you look on the valence electrons ring right here, we have 1, 2, 3, 4, 5, 6, 7, 8. So this element, whatever element it is, has 8 valence electrons. All right? The Bohr's model and Lewis dot model can kind of go hand in hand, because if you count the number of dots in this Lewis dot structure of argon, you can see that this also has 8 dots. And these dots are the valence electrons. All right, so this Bohr's model would be associated with this Lewis dot structure for argon. All right, so let's recall from our last lesson what our atomic number is, and we know that that tells us the number of protons and also tells us the number of electrons an atom has. The letter right here is just the element's name or the symbol, and this bottom number right here is the atomic mass, or sometimes called the atomic weight. And this tells you the number of protons plus the number of neutrons. And if you remember, to figure out the number of just neutrons, you have to take your atomic mass and minus that from your atomic number, and that tells you the number of neutrons in the individual element. All right, still talking about boron. All right, if we were to make a Bohr's diagram for boron, the first thing that we would do is put the symbol in the middle that represents the number of protons and neutrons inside of the element right there. All right, and then you're gonna fill the energy levels, the first one, and then once the first one gets filled, then you can start putting electrons in the second ring. So boron, we said that it has 5 electrons. So we need to have 5 different dots on this Bohr's model diagram. So we're going to put the first 2 dots on the first energy level, all right, and then we're going to put 3 dots on the second energy level. So once the inner ring is filled, then you can start putting rings on the other energy level on the outside. All right, if you were supposed to make a Lewis dot structure or a dot diagram for boron, we know that the Lewis dot diagram shows the number of valence electrons boron has. And the way to figure that out is you look at the outer ring, all right, this outer ring, how many dots per se are on this outer ring, and there are 3. So you can look at this diagram right here. Boron has 3 dots around it. So that tells us that boron has 3 valence electrons. There's also an easy way to figure out the number of valence electrons using the periodic table, because the periodic table tells you a lot of information. If you look at the first group right over here, this entire group has 1 valence electrons, all right, going all the way down. The second group, that has a +2, so this whole row has 2 valence electrons. We're going to skip this over here because they kind of vary in valence electrons. And then this right here where it says +3, that has 3 valence electrons. This has 4, and then this has 5, 6, 7, and then 8 valence electrons in our noble gases. All right, so now let's talk about the 2 different types of ions we can have. We can basically have a cation or an anion. So ions are just elements that lose or gain different types of electrons. A cation loses an electron and makes it positively charged. An anion gains an electron and makes it negatively charged. A good way to help you remember this, you can just remember PCAN, anion, negative, and then positively cations. That works for me. I hope that works for you too, to help you remember that cations are positive and then anions are negative. So, talking about ionic compounds. Are compounds that basically have a metal and a nonmetal held together that has an ionic bond. Metals tend to lose electrons to form positive ions, and remember, positive ions are called cations, PC. And nonmetals, they tend to gain electrons and they form negative ions, which are called anions. All right, AN, anion, negative. And this is just an example of Na, sodium and chloride, and that makes table salt. If you look at our periodic table, the periodic table tells you the different charges in each individual group. You can see this has a +1 charge, this has a +2 charge. The transitional metals, they vary in charges, +3, +4, and then if you start at the noble gases are always stable, and then -1, -2, -3. Right? Noble gas configuration. So if you have elements that basically want to achieve a noble gas configuration, so that just means that elements want to have a full amount of electrons on its outermost energy level. And the most electrons that it could have on the energy level is 8. And we call that the octet rule. All right, and you can see that chlorine has 7. This has a neon, which is a noble gas, that has 8, and then helium has 2. All right, so if there's these different ions, they don't reach their octet level, they can actually either gain or lose electrons in order to get that full number of 8 electrons on the outer ring. All right, some examples of cations. All right, remember cations are positive, sodium. All right, sodium is right here, and if you remember, this has a +1 charge because it's in that group. Tritium, if you look at that, it has a +2 charge. It's in this column right here, and then aluminum. Aluminum is right over here, and that has a +3 charge. So these are just examples of cations. Examples of anions. Anions are negative. Your nitrogen, -3, oxygen, -2, and then your chlorine that you put in pools, that's a -1 charge. All right, hopefully at the end of this video you learned to identify different valence electrons, you understand the properties of ions, you can differentiate between what a cation is and what an anion is, and then lastly you understand how to basically use the periodic table to show you different charges of different anions. Thank you, and if you have any questions, just let me know. That's it.